Hi, I'm Dr. T, and welcome to my office. At the start of the 19th century and before, it was thought that the chemistry of life and the chemistry of abiotic things, such as rocks and minerals, were fundamentally different. And there was some basis to that. If you look at rocks and minerals, those are ionic compounds quite often, or they are covalent network solids, and they do behave differently than the common molecules found in living things that are derived usually around carbon. But of course, in the 1820s, we didn't know any of this. We were just starting to figure things out. And in comes a German scientist by the name of Friedrich Röher. I have probably done a very bad job at pronouncing his name. But what he had done was he reacted two classic abiotic molecules, two molecules that were clearly not from living creatures, silver cyanide and ammonium chloride. He hadn't really planned on doing this. He just kind of put them in the beaker, put them in the sun. Depends on how the story goes, is exactly what you see. And he leaves them, coming back to see some very familiar crystals. What he had discovered was that he had formed a new to that beaker, molecule, urea. Now, urea had been known for quite a while. That's one of the major components of urine. And we had known that for a while because we would boil down urine and extract the urea. It was a useful industrial chemical. It still has quite a bit of use to it to this day, although we're no longer bleaching our clothes with urine. Yeah, that's how they used to clean clothes. Ugh. Anyways, there's a problem. He just took two classic non-living molecules, two things that were good and inanimate, and he just made urea, a classic, what was being called organic molecule, something from a living creature. But there was no living creature. His quote was, and I'm going to read off my screen, "I must tell you that I can make urea without the use of kidneys, either man or dog." Yeah, wonderful poetic. Reading the literature from the 19th century is always fun. It's so much more dry today. But this fundamentally changed the way we were thinking about chemistry. Now, all of a sudden, it was clear that the chemistry of inanimate objects and the chemistry of living things was the same chemistry. There was no fundamental difference. If you could make urea without the use of man or dog, then yeah, things were going on. So why does this apparent difference in chemistry, even though there isn't really a difference? Well, the origin of this idea and the way organic chemistry has heretofore been defined goes around the chemistry of carbon. Carbon is somewhat unique amongst elements. Most elements like to form bonds with other atoms, at least to some degree, looking at you, helium. But carbon likes to form bonds to quite a few different atoms, including other carbons. Most atoms will form bonds, but preferably not to other atoms of their own kind. Exceptions do exist, and they will if they, really want to, but usually you're not going to do much of that. Whereas carbon will get all kinds of weird and elaborate bonding patterns. Just look at things like diamond and graphite, which are pure carbon, at least on the inside. The very outside is a little bit of a different story. This means that carbon can be put into chains, and if you make chains, you can also rearrange them so that you can have carbons going in a straight line, going in forks, and that's actually going to be really important. So when it comes to carbon, you can take the same chemical formula, the same molecular or same empirical formula, but have two completely different chemicals. These are what we call isomers. Isomers are, from their name, same molecule, even though they're not the same molecule. These are two compounds that have the same chemical, either molecular or empirical formulas. Well, it would be both molecular and empirical formula, but they are fundamentally different chemicals. The number of carbons, the number of hydrogens, and other things in them are the same, but they're rearranged differently, and this leads to a different molecule. Methyl ether and ethanol both have the same chemical formula, C2H6. H6O, but one's liquid, one's a gas. They're definitely different compounds. And so when we're talking about organic chemistry, we're going to be able to make a huge variety of compounds by simply rearranging the atoms. And that is going to be the origins of our compounds for living creatures. Most of those compounds, not all, but most of them, are going to be carbon-based and are going to be different ways of rearranging carbon, hydrogen, and a few other elements, specifically oxygen and nitrogen. More on that when we talk about biochemistry. One last point I'd like to talk about when it comes to organic chemistry, that is the idea of hydrocarbons. This is a large group of organic molecules that consist of carbon, hydrogen, and depending on who you ask, because like all words in all languages, but definitely English, the dictionary is fuzzy, but hydrocarbons are going to contain carbon, hydrogen, that's where they get their name, hydrogen for hydro and carbon for carbon. They may also contain things like oxygen and nitrogen. This is going to be a fairly important area of chemistry for us. We use these heavily for fuels as well as building blocks for other things. These are kind of your core organic molecules. You can get fancy by adding other weird elements to them, but this will be the backbone. And more on that in later videos. With that said, have a wonderful day.